Hello, and welcome to another mini lesson about propositional logic. We're continuing to talk about proof methods, and this is going to be the first of several which use a method which is basically just reduction using given rules. So before we start talking about how to do proofs using this method, we're going to show you what our given rules are, our laws of logic here. So these are some fairly basic laws of logic, which are things that can be pretty easily proved using a truth table and have been repeatedly proved using truth tables, to the extent that they're just taken for true statements. And it's very easy to prove these. You can do that in your free time, and probably you'll do some on your homework as well. I'm sorry that these are very small and very busy. If you want to see them up close, so that you can reference them for yourself, you should probably look in the book. They're all given in the book. And you can reference these. They're also available online, all over the place. But what these basically say is that anytime you have two statements, for example, linked by or, you can swap those statements around, right? Any Q and any P can be swapped around in this way, right? So that's what these say, and they allow us to reduce complicated statements to simple statements. So we're going to start off by doing an example that is in your book, and we're going to take you through step by step to make sure you're understanding how it's all working, and then we will talk about some other examples so that we can see some new ones that we haven't seen so far. So this is a statement, if P, then not Q or P, which is claimed to be a tautology, and you can prove fairly easily with a truth table that it is a tautology, but we're not going to do that here just because of space. But you can see that proof with a truth table in your book if you doubt me, and we're going to do this by just reducing the statement in terms of its size. So the first thing that we do when we're doing a proof like this is we number our steps, right? We make sure our steps are going to have numbers. And the first thing that we do is we put the original statement at the top, and we label that as our given statement, right? So our original statement is the statement that we are proving is a tautology. Just put right there, and we write given next to it, right? That's how we know that that is the case, or is allowed to be introduced into our proof because we were given it, and we're going to reduce it using our laws to some format that is more usable. So we have to choose from our many, many laws what we want to do first. So the first thing that we notice is that this contains a conditional, right? We have this unidirectional arrow, this one-directional arrow, and most of our laws don't include that, right? We have conditional laws over here that include an arrow, but most of our laws don't include an arrow. So a good first step if you have a conditional in your proof is to get rid of it first, right? That can be the first thing that you do, is get rid of your conditional. So we look at our conditional laws, and most of these let us pretty easily get rid of a conditional. 2 of these let us get rid of a conditional. We're going to choose for our first step to select this one, right? This first conditional law. So what does this mean? This means that on one side we have if P then Q is equivalent to not P or Q, right? These are logically equivalent. We've proved this. So we can say that this is P then Q, right? And so we can reduce this to not P or, and then everything that is our Q statement. Right? And then we have to say, how do we know this? Because of our conditional laws. Right? That's a conditional law. Okay. What do we want to do now? So we're looking at this statement that we now have. We've got some ors. This is really nice. We're reducing the number of different linkers that we're using. And we have a couple of instances of P. Now we want those to be sort of close to each other, right? So the first thing that we're going to do is move things around so that they're close to each other. Now our moving things around rules are our commutative properties, right? So our rule for or is P or Q is equivalent to Q or P. We have this or here, And so we're just going to swap the position of these two statements around, and we're going to put our not Q or P statement and then say or not P. Right? So all that we've done is we've swapped this and this, right, around this or. So this is like our little hinge here, right? We've just flipped them around, and then we have to say we're using a commutative property. And that's how we know that we can take that step. All right, so we've now got these next to each other, but they're not in the same parentheses as each other, right? So we're going to have to figure out what we want to do with our parentheses. So our laws that deal with what is parenthesized together are our associative properties, right? So here we have, this is the one to do with or, right? P or Q or R is equivalent to P or R, Q or R, right? And this is exactly the type of statement we have here, right? We have the first two in parentheses, and we want to get the second two in parentheses together. So we're just going to really quickly say not Q or P or not P by the associative property. Right? So this is starting to look like we might be able to reduce it. All right, so we have P or not P. This is actually one of our complement laws, right? And we're going to go and look at our complement laws and see what that lets us do. So where are our complement laws? We actually proved this one was a tautology in one of the previous videos. So if you want to see that. So this is P or not P is always true, right? And if you want to go back and see the video to see why that's the case, you can do that. So what we're going to do here is use a complement law to just replace that entire statement with truth, right? That just means true, right? And we're going to label that with a complement law. Is how we know that that's the case, right? That's what we've done in between this step. In this step is used a complement law. All right, finally, we have a statement or truth. So in this case, we're going to go look at our domination properties. So for step 6, I changed my labeling methods, but we're going to look at our domination properties, right? So we have some statement or truth is always true. And you can prove this using your truth table. But we have some statement or truth, and that is always going to be true. So we can say that the whole thing is just truth, which is done by a domination property. And then we can say QED. I'm doing this again. Because we have reduced this statement step by step using only things we know to be true down to just truth. And there we've shown that it is a tautology because it is always true. Using things that are always true, we can show that this is just a complicated way of saying truth. All right, so that's our first example of a proof using these various laws of logic. Tune in to the next one for another example.